Okay, welcome back. Here's part 2 of trigonometry in the Cartesian plane. We're going to kind of start where we left off. We talked about alts and tan cos and how that affects the sign of our trig values. I just want to do an example here to show you how it kind of all works and comes together. So here's my angle theta, and I want to know the sine. We'll just do sine, cosine, and tangent. So I want the sine of theta. I'm going to want the cosine of theta. And I'm going to want the tangent of theta. Okay, so what I need to do first is to draw my reference triangle. So I'm going to take the point -3, -4, which is on that terminal side. I'm going to drop a perpendicular to the x-axis, and I have a right angle and a right reference triangle. So I'm going to call this theta prime. That's my reference angle. Now the trig values for the reference angle are going to be identical to the trig values for my angle theta, with the exception of possibly the SIGN on these values. So I come over here and I say, okay, the first thing I need to know is what's R? So R is the square root of the x-coordinate squared, which is 9, plus the y-coordinate squared, which is -4. -4 squared is 16. So R is the square root of 25, which we know is 5. Okay, so I can put that over here on my picture, and I know that R is 5. So when I come over here to my trig values, the sine is y over r. So that's y over r. Now in this case, my y-coordinate is -4, and I found that r was 5. Cosine is x over r, and so that is going to be my x-coordinate, which is -3 over 5. Okay, stay there. Alright, and then my tangent is y over x. Y is -4, x is -3, so together -4 over -3 is a positive 4/3. So if I look at alts and tan cos, I'm in quadrant 3, which tells me that tangent should be positive, and it is. And everything else should be negative. So I've got this fraction's negative and this fraction is negative. So I found that out by just using the x and y, but I can certainly do a quick check with alts and tan cos to make sure that I did indeed get a negative sine, a negative cosine, and a positive tangent. Okay, so let's move on. Okay, let's look what happens when instead of r being changing depending on what x are, what happens if we freeze r at 1? Let's go over to our definitions. If r is 1, then y over r becomes y over 1, which is just y. Cosine of a, instead of just being x over 1 or x over r, it's just x. Looks like tangent and cotangent are going to be the same, but if I take r out of the equation, it's going to look a little bit differently. And what I want you to catch here is that the sine of a is just the y-coordinate here. And the cosine of a is just the x-coordinate. So let's take a look a little bit further. So it looks like as long as we let r be 1, we will have the cosine of a will be the x-coordinate, and the sine of a will be the y-coordinate. So this is that same reference triangle. We did one with a -4 and -3 as my x and y. Well, if I freeze r at 1, then whatever I get, whatever these coordinates are, the sine of this angle is going to be the y-coordinate. The cosine of this angle will be the x-coordinate. So if I can just look at a triangle with a 1 for the hypotenuse, it will be really easy to find the sine and the cosine if I just know the point xy. Alright, so if I look at a circle that has a radius 1, R stands for radius. So if I take any angle and I rotate my terminal side anywhere around this circle, as long as I have R equals 1, then the x-coordinate is going to be the cosine of theta, and the y-coordinate is going to be the sine of theta. Now let's say I have an angle that's over here. I don't know what these points are, but I do know that if it's a point on this circle, then it's 1 unit away from the origin here. And if I look at my reference triangle, the coordinates of this point are going to be the cosine of, I guess let's call this one beta. The cosine of beta, comma, the sine of beta. Anywhere around the unit circle, if you have a point on the unit circle, it is going to stand for example, I'll just put a point here. If I have a point, the coordinates of this point will be the cosine and sine of the angle that goes through that point. So let's call this one alpha. So if I have this angle alpha and I've got this point, this will be the cosine of alpha and this will be the sine of alpha. So you can see that the points around here on this circle are pretty important because every single point around here corresponds to the sine or the cosine of an angle that I can make. For this reason, because this is 1, we call this the unit circle. 1 unit. It's called the unit circle. Now, if you think about it, our regular coordinate system, you know, when we make our XY coordinate system and we mark it off, we mark off our units, we say, okay, 1, 2, 3, 1, 2, 3, and so forth. What I'm doing is I'm taking this right here. This is that circle with radius 1. I'm taking this circle and I'm blowing it up really large so that I can get a better look at the points that are around that circle. But the same thing is true here. Any point on here is going to be the cosine of my angle and the sine of my angle. Okay, so let's take a closer look at the unit circle. Okay, it's time to start filling in different values on the unit circle, and we're going to start with the 30-degree angle. Now, last week I showed you the special angles, the 30-60 triangle and the 45-45, and I told you would be memorizing that. Well, it's time. Here's a 30-degree angle, and if I make a reference triangle, I know that this angle here must be 60 because it's a right triangle and the two angles have to add up to 90 degrees. Remember that it's a unit circle, so R is 1. So let's see what we have here. Remember when we did that and R was 1? This would be half of that because remember it came from an equilateral triangle. That's 1, 1, and 1. So that means this must be 1/2. And if you remember from last week when we did the Pythagorean theorem, this side ended up being radical 3/2. So if that's the case, then this point right here, the point xy, is cosine, sine. So my x-coordinate, how far I had to come over here, is radical 3 over 2. How far I went up is 1/2. So the coordinates of this point, if I start with 30 degrees here, with a radius of 1, I get x-coordinate of radical 3 over 2, y-coordinate is 1/2. Now remember, because it's a unit circle, this is the cosine of 30 degrees, and this is the sine of 30 degrees. All right, so let's go from there and let's look at the other triangles that I can get with the same reference angle. Okay, what I've drawn on the circle here are the 4 30-degree reference angles. Now, if you look at the points and see how they're related to these coordinates. For example, this point right down here, it's directly below this, so it's going to have the same x-coordinate, radical 3 over 2. If I look at this distance here, I went up 1/2, so this must be down 1/2. The y-coordinate is negative 1/2. Alright, over here, I had to go left the same distance that I had gone right here, but I go up the same. So this is, because these points are straight across from each other, they have the same y-coordinate. They both go up 1/2 unit. So this one is going to be negative radical 3 over 2, comma, 1/2. And then look at this one down here. It's going to have the same x-coordinate as this point because they both go to the left the same distance. It's going to have the same y-coordinate as this point because they are directly across from each other. So let's fill this back in. And this point is going to be negative radical 3 over 2, comma, negative 1/2. Okay, so now let's take a look at what the actual theta would be for that one. This one is 30 degrees, so I'm just going to go ahead and write 30 degrees here. This angle, this theta, the one that has a reference angle of 30 over here, would be 180 minus 30. This angle for theta is 150. Now I'm just going to write that right here, right by where it terminates. That's 150 degrees. If I look at the next angle, which would be this one, if that's theta, my reference angle is 30, but my actual theta is going to be 180 plus 30, which is 210 degrees. Okay, now if we do our last angle, it's going to start here at the x-axis and it's going to rotate around, all the way around, and end up here. So that's actually just going to be 30 degrees shy of 360. So this theta would be 330 degrees. So I'm going to just write that here, 330 degrees. So now, if I ask you what the sine of 30 degrees is, you're going to tell me 1/2. If I ask you what the cosine of 150 degrees is, you're going to tell me that the cosine of 150 degrees is negative radical 3 over 2, because the cosine is the x-coordinate for that angle. If I ask you for the sine of 210 degrees, that's the y-coordinate. And that's how it works for all of these. So now we're done with the 30-degree reference angles. Let's take a look at the 60-degree reference angles. Okay, so let's look at the 60-degree reference angles now. If this is 60 degrees, this has got to be 30 degrees. The radius is 1. Now this is the same triangle that we had in red, but it's oriented a little bit differently. Now this is 1/2, and this is radical 3 over 2. So the coordinates of this point are going to be 1/2, comma, radical 3 over 2. Alright, so now if we look straight across, it's going to have the same y-coordinate, and it's going to have the negative of the x. So this one is going to be negative 1/2, comma, radical 3 over 2. And if I go straight down, this is going to be negative 1/2, negative radical 3 over 2. So negative 1/2, negative radical 3 over 2. And then this one is going to be a positive 1/2, negative radical 3 over 2. So positive 1/2 and negative radical 3 over 2. Okay, so now let's take a look at what those angle measures are. We know that this one is 60. And then if I rotate over here, it's going to be 180 minus 60, that's 120. And then if I come back and rotate over to this one, that's going to be 180 plus 60, which is 240. And then if I do the last one, rotate all the way around to here, it's going to be 360, backed up 60 degrees, so this is 300. Alright, we need one more set to look at. We're going to look at the 45-degree angles. Okay, let's look at the 45-degree reference triangle that we did at the end of class last week. Again, if my r is 1, then using Pythagorean's theorem, I'm going to get radical 2 over 2 and radical 2 over 2. Okay, now we went through the math of that last week, so I'm going to leave it to you to verify if you want to. That means that the coordinates of this point are radical 2 over 2, comma, radical 2 over 2. Which makes sense, because if you look at a 45-degree angle, that's halfway between 0 and 90. So you would expect the x and the y coordinates to be the same. Now if I go straight across here, I'm going to have negative radical 2 over 2, comma, radical 2 over 2. Over here I'm going to have negative radical 2 over 2, comma, negative radical 2 over 2. And then over here, I'm going to have positive radical 2 over 2, comma, negative radical 2 over 2. Now let's put in our angle measures and we'll be in good shape. So this one is 45, and I've got that written there. Now if I do the rotation to this one, that's 90 degrees plus 45, that's 135 degrees. If I go all the way to here, that's 180 plus 45, and 180 plus 45 is 225. And then the last one, I go all the way around the circle. I am going to be 45 degrees shy of 360, and that's going to put me at 315 degrees. Okay, so let me clean this up a little bit, and we have one more thing to do. Okay, now that we've got that a little bit cleaned up, there's one more group that I want to put on here. And just look at, and those would be the quadrantal angles. Now, this is either going to be considered 0 degrees or 360 degrees. I'll get to the same place if I go all the way around the circle, or if I just put the initial and the terminal sides right here. The coordinates of this point are 1, 0. This is 90 degrees, and its coordinates are 0, 1. Over here, this is 180 degrees. The coordinates here are negative 1, 0. And down here is 270 degrees. And the coordinates here are 0, negative 1. Okay, now, to top this all off, let's just review again. If I'm on the unit circle and the radius is 1, then the coordinates of these points represent the cosine and the sine of the given angle. That also carries over to 90 degrees and 180 and 270 and 360. If I say what is the cosine of 90 degrees, you cannot make a right triangle and do SOHCAHTOA on the 90-degree angle. But using this method, I can say that the cosine of 90 degrees is the x-coordinate, which is 0. I could come over here and say the sine of 180 degrees, that's the y-coordinate, that's 0. If I ask you just a few questions, if I say, okay, find what's the sine of 120 degrees? The sine of 120 degrees is the y-coordinate right there, radical 3 over 2. If I say, what's the cosine of 330 degrees? The cosine of 330 degrees is radical 3 over 2. What if I say, what's the tangent of 225 degrees? Well, the tangent is y over x. Now, this is something over itself, so the tangent, I should mark that in another color, the tangent of 225 would be 1, because anything over itself is 1. If I say, okay, tell me the cosine of 300 degrees. You find 300 degrees, cosine is the x-coordinate. So you see how this works really well for all of these basic special angles, the 30s, 45s, 60s, and 90s. If you know these coordinates, you will know what the sine and cosine are, and you can quickly figure out the tangent by taking the y over the x. Okay, for that reason, day 1 of your assignment this week is to memorize this unit circle. But hang on, we're not quite done. Okay, before we go on to the part 3 video, I just wanted to show you this. I've kind of shrunk it down a little bit. This particular page is in the overhead masters file. So if you want to print this out, even if you just do it in black and white, if you want to print it out so that you've got all the angle measures and the coordinates, you're very welcome to do that. I also have a blank unit circle in those overhead masters as well, if you want to practice figuring out what goes where. So we have some more to add to this in the next lesson, so we'll see you there.